January 2005, NASA launched a unique probe into space. Its mission? To uncover the mystery of Earth's water. Where did it come from? The probe, named Deep Impact, traveled 270 million kilometers to reach a comet. Within this comet lay secrets humanity had been searching for over centuries. Welcome to another video. In the entire universe, Earth is the only known place where humans can survive. It feels as if Earth was made just for us, equipped with everything essential for life: water, food, and oxygen. While we cannot be sure if there's another planet like this in the vast universe, Earth is the only place we know of where life exists without external aid. But 5 billion years ago, Earth didn't exist. The space where Earth and our solar system now exist was at the edge of the Milky Way galaxy, occupied by a giant cloud made of dust and gases. What transformed this dust cloud into the planet we now call home? This cloud, known as the molecular cloud, contained dust particles, sand, silicon, and other essential metals. This cloud formed from the remnants of dead stars that had burned through their fuel and exploded, scattering debris across the universe. Captured by the Hubble Space Telescope, these clouds were colossal, 100 light-years across. To understand their size, imagine light traveling from one end to the other of the cloud. It would take 100 years. Compared to the distance between the Earth and the Sun, this cloud was 6 million times larger. This massive dust cloud, capable of forming stars and planets, was driven by gravity, the same force that draws objects in space toward each other. In the molecular cloud, larger particles began attracting smaller ones, causing frequent collisions. These collisions generated energy, heating the cloud's core, which started to rotate and grow in size. Over millions of years, this process intensified, and the core eventually became a giant fireball, our Sun. The leftover cloud particles started orbiting the Sun, eventually forming planets, moons, and other celestial objects. But how did this happen? The process of planet formation was first hypothesized in the 1700s by German philosopher Immanuel Kant and French scholar Pierre-Simon Laplace. Their ideas gained traction in the 20th century when advanced telescopes allowed astronomers to observe dust clouds where new stars were being born. However, the interiors of these clouds remained hidden until the development of radio and infrared telescopes in the 1970s and 1980s. These breakthroughs enabled astronomers to witness star formation within molecular clouds and observe how leftover particles later formed planets. But what triggers this process? In 2003, an experiment aboard the International Space Station provided a breakthrough. Astronauts conducting experiments to observe behavior in microgravity made a surprising discovery. In one experiment, when salt particles were placed in a spinning plastic bag, they clumped together due to mutual attraction, a simulation of how molecular cloud particles stick together to form planets. Approximately 4.5 billion years ago, particles in the molecular cloud began forming clusters. Once these clusters reached the size of a mountain, their gravity intensified, attracting more particles and growing larger. Over the next 30 million years, this process gave rise to 20 protoplanets orbiting the Sun. These large protoplanets, driven by their gravity, began colliding and merging. Over time, these collisions reduced the number of planets to the few we know today: Mercury, Venus, Mars, and Earth. However, Earth was far from the blue, life-sustaining planet we see now. Instead, it was a fiery, molten mass with a temperature of 5,000 degrees Celsius. At this stage, life could not exist. the planet needed to cool down significantly. As Earth gradually cooled, it faced a significant threat: solar storms. These storms, emanating from the sun, could strip away a planet's atmosphere, rendering it uninhabitable. Mars, Earth's neighbor, suffered this fate, but Earth survived thanks to its magnetic field. Earth's core, composed of molten iron and nickel, generates this magnetic field. Spinning molten iron acts like a dynamo, producing a magnetosphere that extends over 370,000 kilometers, shielding Earth from solar radiation. This protective shield allowed Earth to survive solar storms, but it was still not hospitable for life. One final dramatic event would change everything: the formation of the Moon. In the 1960s, during the Apollo missions, samples collected from the Moon revealed something fascinating. While the Moon and Earth share similar oxygen isotopes, the Moon's rocks appeared burned, indicating a violent origin. Scientists theorize that the Moon formed when a Mars-sized planet, Theia, collided with Earth. The impact ejected fiery debris into orbit, which eventually coalesced into the Moon. This collision tilted Earth's axis by 23.5 degrees, giving rise to seasons. The tilt ensures varied temperatures, diverse ecosystems, and rainfall patterns, enabling life to thrive. But for life to exist, one essential ingredient was still missing: water. In 2005, NASA's Deep Impact Probe targeted the comet Tempel 1, crashing into it at 38,000 kilometers per hour. Spectroscopic analysis revealed that comets contain water in the form of ice. Scientists believe that Jupiter's gravity played a key role in redirecting comets toward Earth billions of years ago, delivering the water that now covers 71% of our planet. Evidence from ancient zircon minerals shows that water appeared on Earth about 4 billion years ago, 500 million years after the planet's formation. The combination of Earth's tilt, the Moon's formation, and Jupiter's gravitational influence created the perfect conditions for life. The planet, once a fiery inferno, had transformed into a haven for life. But what about oxygen? Let us know your thoughts in the comments. Thank you for watching, and we'll see you in the next amazing video.